Quantum Odyssey is nothing less than visual mathematics. It means that everything you see in the circuit, including this simple case represented, is actual visual mathematics. State of the qubit starts from 0. That's why you have this number here. It's initiated in the 0 state and it goes to the 0 state. The first puzzle tasks you to move the state from 0 to output 1. To do this, as you can see, will require us to change the tensor. So by adding this simple X gate, analyzing it, we'll understand that there is a difference here in how the tensor product is presented. So from the completely diagonal numbers, we'll get numbers on the off diagonal, which once they are multiplied with the state vector, you will see the state vector has flipped. This is the first puzzle. Very straightforward. Then for the second state, we are shown that this state is reversible. So whenever we have an X gate, adding a simple X gate, no matter if before or after, we'll be able to reverse the state back to 0. For the third, we see that we're tasked from going from input 0, 0 to output 0, 1. To do this, we need to understand the difference between these two qubits. So whatever you place under the column of qubit 1 will change the state of the leftmost qubit. If you look at the numbers here, the leftmost number corresponds to whatever is happening on qubit 1. You can see it being highlighted right now. The same goes for qubit 2. As I'm navigating, I'm shown in real time what I will change and where it will change. But take in mind that we're altering the whole space of computation, meaning even if we were to start from 1, 1, we would go to 1, 0, because we place the gate on the rightmost qubit. But in this case, from 0, 0, we can get to 0, 1 by simply changing whatever the rightmost qubit state is to make sure it's 1. In the fourth example, we are tasked with changing the leftmost qubit. Again, you'll see the visual looks different because we see in real time everything that happens and everything that can happen. That's the power of the forge. And now, when we have two qubits that want to be flipped, we need to add two X gates. As you can see, it doesn't really matter where I add these. I can construct some pretty visuals, but that won't change anything besides the fact that I'm gonna get the right output if I have an X gate on each qubit. And now, for 3 qubits, my space has, well, went to the power of 2 once more, right? So if you want to get from 0, 0 to 0, 1, 1, quite straightforward, 2 X gates. I don't get many options here, and I got 0, 1, 1. And now for the 7th puzzle, we are tasked with making sure that the leftmost qubit is flipped. And let's do this right now. Again, doesn't matter what I put this X gate, it will only affect the leftmost qubit, although the visuals will look insane depending on the location. And I also need to reverse these two, right? And to reverse these two, again, doesn't matter what I put in my X gates, I will create a pretty visual and I will get to where I want to go. And this is everything you need to know. Pay attention to the columns. The columns show you which bit will be flipped. So if I want to flip, let's say the middle one, make sure I don't put anything on any other qubit. Make sure that only the middle one has a single gate. Whenever I want to nullify the effect of existing X gate, simply add another X gate into the circuit. And that's all you need to know.